1.6. And we're going to talk about and or. Now, an and, what does an and mean? And means both. If I say Jill and Joe walk to the store, what does that mean? That means they both walk to the store. It's also called an intersection. And it's going to be where the lines, where the graphs overlap. So when we go to graph these, that's where they're going to overlap. And we represent an and with an upside down U. So an and is both. An and is going to be where they cross each other, where they overlap, and we can represent it with the upside down U. And or. Well, what does an or mean? An or is all of it combined together. So it's either one or the other, right? If I say Jill or Joe walk to the store, what could happen? Jill could walk to the store, Joe could walk to the store, or they could both go. So or means either one. And that's called a union. And what we're going to look at for the graphs is we're going to combine the graphs. And we're going to represent that with a U for union. So we've got and we've got an or. We don't really use the intersection symbol much. We do use the union symbol quite a bit. The U means we combine them together. We're going to graph a couple of these, and we're going to look at the 4 different outcomes that can happen. So we're going to graph these inequalities here. Okay, so let's see what we've got here with this. Now this is an or. What we're going to do is we're going to graph both of these. And I'm going to try to use different colors, so hopefully you can see the 2 different graphs. So let's look at x is greater than or equal to 3. I'm going to try and graph this one in blue. So we've got our 3 here. And which way does it point? Okay, this one, we're going to graph it first, and it's going to point to the right. So we're going to shade to the right. And it's going to get square brackets. Everyone all right with that so far? Now let's do the other one in green here. And what about this one? This one's 9. And which way does it point? Yep, it's going to point to the left, isn't it? Right, the way it points. So we're going to shade back to the left. And we're going to use parentheses here. Now, what is happening with this one? Okay, this is an or. Now, or means we combine them all together. Now, if I combine these all together, is there any part of the graph that is not shaded at all? No, because it's shaded here and it's shaded there. When we combine them all together, what does it give you? It shades the entire graph, so your answer would be what? Negative to positive infinity, because it shades the entire graph there. Now let's do a similar problem, but let's look at it in terms of an and. So let's change this, change the numbers, and we'll make it an and. So how about we say x is greater than 5 and x is less than 12. Okay, now very, very similar on this one, but the answer is going to be completely different. Okay, so when we look at this one, again, we're going to use the two different colors. Hopefully they kind of show up here. So we're going to do the first one in blue. Now we've got the 5. Okay, here's my 5. And which way does it point?
The right.
It points to the right. So we're going to go ahead and shade to the right. We're going to use parentheses here. What about the other one? Okay, 12, and it is pointing where? It is pointing to the left, so I'm going to use the green here. Now, what's the difference? When we had the or, what did the or mean? We put it all together. Okay? Now, what does the and mean? And means the intersection. It's where they overlap. And if it's an overlap one, then what does that mean? It means the intersection where they overlap. Where do they overlap from? In terms of interval notation, they overlap where? Right in the middle, right? And so they overlap from 5 to 12. Do we see the difference between the and the or? Okay, or means you put them together and add everything. You can't say add, but splice all the pieces together. And means you look at where they overlap, what they have in common. Now let's look at two more examples here. Let's look at this one. And again, we're just going to graph these. How about we say x is greater than or equal to 2, or x is less than minus 5. Okay, this one's going to give us a little bit of a different answer here. So let's see what we got on this one. So we've got x is greater than or equal to 2. So here's my 2. And in this case, this one is pointing to the right. So we're going to use a square bracket at the 2. And we're going to have to shade out to the right. What about the other one? The other one is a negative 5, and it's pointing out to the left. And it's strictly less than, so we're going to use parentheses here. Is everyone okay with the graph so far? Now, what does the or mean? Okay, or means we combine them together. Now, when we put these together, we're going to have to use a U for union. So we start with negative infinity on the left, and we end with positive infinity on the right. So in interval notation, we've got negative infinity to negative 5, okay, both with parentheses. Our other piece is 2 with the square bracket to positive infinity. And what do we put in the middle? We have to unite them together, so we use a U for union. It's not the entire part because we have a piece that's not shaded at all, right? This piece right here, it's not shaded. So it's basically saying, if you think of the or, the U for union, think of it like a plus. It's basically like the green piece plus the blue piece. And use a U to represent that because we can't use a plus for sets. But you put in the pieces together. One more example, and then we'll look at some where we have to actually solve them. So let's do one more example here. And again, we're going to try and graph this one. And how about we say x is greater than or equal to 18 and x is less than 2. This one's going to give us a completely different answer. First one, we'll graph it in blue. We've got our 18, and it is greater than or equal to. It's pointing out to the right, so we use a square bracket, and we'll shade to the right. X is less than 2. Here's my 2. And this is less than. It's going out to the left, right? Points to the left, so we shade it to the left. Now, how is this one different from the last one in terms of the answer? Right, the graphs look the same, but the answers are completely different. This has an and. And an and means where they overlap. And these never overlap. So since they never overlap, we represent that with the empty or the null set, right? Because they never overlap at all. So and means overlap, or means we just simply put them together. We'll pick a couple of problems from our textbook. And like I say, these are actually quite a bit easier than the stuff out of 1-4. I think you'll find 1-3 and 1-4 to be the most challenging. After that, though, it's a lot easier. The and the or might be something that's new to most of you, but it's not difficult to work through. So let's pick out a couple of these to actually work through. And I'll pick these from our textbook. This way we get good numbers to look at. How about we look at on page 122? Let's look at question 44. We've got minus 2x plus 1 is greater than a minus 11, or x plus 1 is greater than 10. So this is what we've got here. So this is going to be what we're working with. First thing we notice is what do we have in the middle? We have an or. And we're just going to separate it in half and work out each side separate from the other. So let's just go ahead and work through this one real quick here. We're going to do the left inequality first, so we're going to move that 1 over with subtraction. Now we've got a minus 2x is greater than negative 12. Okay, I picked this one on purpose because what are we going to have to do when we divide by a negative 2? That inequality symbol, it gets flipped. So make sure you flip that around. And negative over negative makes it a positive, and that's going to be a positive 6 there. The other one, what happens with it? Move that 1 over, and that gives you x. Do we flip our inequality symbol? No. Why not? Did we divide by a negative? No, we did not. So the inequality symbol stays the same, and 10 minus 1 makes it a 9. Now, all we have to do is to graph them. So these are not difficult at all. They're actually, I think, a lot easier than some of the others. So now all we have to do is graph them. And the first one is pointing to the left, and we're going to start here at a 6, and it's pointing to the left, so we're going to shade to the left, and it gets parentheses. And just so we remember, strictly less than, strictly greater than, parentheses, greater than or equal to, less than or equal to, those get, again, your brackets. That's the only part you have to remember. And the other one is x is larger than 9. So it is pointing to the right, so we shade to the right. What's in between them? Or. So what does that or mean? Or means we combine them together. So negative infinity, positive infinity. So we have negative infinity, comma 6 with parentheses. We use a U to represent the union. 9 to what? Positive infinity. So there's your answer right there. All you have to basically remember is an and means you combine them, or means you look at where they overlap, or means you combine them together, add them all together. Okay, let's try a couple more of these, and then I think there's one application, but it's actually pretty easy, and I'll help you set it up as well. So let's look at one more of these, and I'll just pick one that looks good out of the homework, or out of the textbook here. So let's look now at question, we'll do 62. Okay, let's look at question 62. 2x minus 6 is less than or equal to negative 18 and $2x is greater than or equal to a negative 18. That looks right. Okay. Now, what are we going to first look at? We have to remember that this is an and. And this one also says, well, I guess it doesn't, but some of them will say, tell me if it's an intersection or a union. Some of your homework questions say also solve it and tell me if it's an intersection or a union. So this is an and that tells you it is a intersection. And some of them may do that. So if it does, and is an intersection or is a union. Just remember that fact if it asks. Some of them do, some of them don't. Let's go ahead and solve it. So add your 6 over. And now we've got 2x is less than or equal to a negative 12. Divide by 2. Do we flip the inequality symbol? No. Why not? We're not dividing by a negative 2. We're dividing by a positive 2. So it stays the same. That's going to be your negative 6 there. What about the 1 on the right? We divide by our 2. Do we flip it around? Nope. It stays the same as well. A negative 18 over 2. Well, that makes it a negative 9, doesn't it? Now, I picked this one because we have to make sure we put them in the right order. Remember, when we look at these, make sure the smaller number is on the left. Negative 9 is a smaller number. So we've got negative 9, and we've got negative 6. Negative 9 is on the left. Make sure you realize that because it's a negative and it's small. So when we look at this one, we've got a negative 6. We'll do it first in blue. And which way is this one pointing? Left. Okay, this one's pointing to the left, and we're going to use a square bracket up. So there's that. What about the other one? Negative 9 is over here, and what does it get? Square bracket, and which way is it pointing? To the right. Yep, so there they are. Now, what does an and mean? Yep, and is where they overlap. And where do these graphs overlap? Overlap between -9 and -6. And that's it. That's all you have to do. So don't try to make this section more difficult than what it needs to be. You just break them down into two separate ones. If you want to use a colored pencil to keep track of things, you can. And if it makes it easier to use two different colors of pencil or pens, like I do here, so you can keep track of them, that's something that you can do as well. Now, number 10, I am not going to work much of it out, but number 10 from your homework, I am going to set up one part of it. There are several different decorators here. There's 6 of them. I'm going to do one of the decorators, and you can use it to figure out the next ones. So homework 1-6, we're going to look now at question 10. What we're doing on this one is we're trying to figure out if these decorators have enough wallpaper, or if they have enough paint, or if they have both. And I like this question because it's something you may have to actually do. Each of the 6 decorators has to paint the room, only the walls, and put a wallpaper border around the room at the ceiling. So 1 gallon of paint covers 400 square feet, and 1 roll of border contains 5 yards. Each decorator has 1 gallon of paint and 3 rolls of border. Here are the decorators, and we want to determine who has enough paint or the border or both. Yeah, cut off that last part that should be or both. So we want to know which one of the decorators of these listed here can either do the paint, the border, or both. Now let's think about how we set these up. When we go to paint, we're looking at an area. When we go to put border up, we look about at the perimeter. Okay, so border, you're going to do a border around the room, so you just measure the room out. Paint, you've got to do the wall, so that's an area. Let's first talk about the paint. When we talk about the paint, we have 1 gallon. Okay, so we've got 1 gallon of paint, and it covers 400 square feet. So that's what we've got. Now we need to see if we can actually paint this room or not. We may be able to, we may not. Some of the decorators can paint the room, some of the decorators cannot. These rooms also have an 8-foot tall ceiling. It says somewhere about the ceiling. Yep, it says 8-foot tall ceiling. So let's diagram this first room. So let's look at Jane. And let's try to draw Jane's room that she's got to paint. And so if you wanted to estimate how much paint you need, every gallon of paint that you buy at the store kind of tells you how many square feet it should approximately cover. How do you figure out how many gallons I need to buy? Well, you look at your room and you figure out how many square feet of paint are in that room. Now, we don't worry about the doors because that's just extra, because a lot of rooms you're going to have a door, at least a door, you may have a door and windows, and that's just some extra paint. So that's kind of your slack. But if I wanted to figure out if I need 1 or 2 gallons of paint to do this room, I would just draw a picture of the room and then calculate the area. So let's see what we've got. This room is 9 by 12. And we know the ceilings are 8 foot tall. That's your ceiling. Now, if I'm looking at the area, we've got a front, right, and we've got a back wall. So let's look at the front and the back. If I look at the front and the back, they're the same. And the front and the back are 8 by 9, like that, right? Okay. So what's this area? Length times width. So that's 8 times 9, and that's what? 72, isn't it? Now, how many of these do we need? We need 2, because we have a front and a back. So we've got to double it. So we'll double our 72, and that comes out to be what, 144? So that's 144 square feet so far. Now, are we done yet? Yeah. Nope, because that's the front and the back. How do we do the sides? Same way. So when we look at the sides, what do the sides look like? Well, the sides look like this, and we have a left and a right. And the sides are 12 feet long, 8 foot tall. So that would be the area is then 8 times 12. And we've got to double it again, don't we? So we have 8 times 12, which is 96. And then we have a left and a right. So we have to double it. And that gives you then 192. What's my total area? That's square feet. Total area is 144 plus 192. Adding those together, I get 336 square feet. Now, can I paint that room? Yes. Yes, I can paint the room. Since 336 is less than the 400, right? So the first part I can paint the room. Now this is something you may have to do. I mean, if you're painting a house and you really want to kind of figure out how many gallons do I kind of think I'm going to need. This is a really easy way to estimate it. All you have to do is calculate the area of that room. You're going to have a little bit of extra because of the doors and the windows, but it gives you an idea of how many gallons I'm going to probably have to have. Rough estimate. Now, what about the border? And then we're going to now look at the border. Okay, so this is going to be the border. We're still looking at Jane. And the border, we have 3 rolls. And each roll is 5 yards. Let's go ahead and make it all feet. So if we've got 5 yards, how many feet are in a yard? Well, 3 feet in a yard, right? So we have 5 times a 3 gives you 15 feet. And then how many total do we have? Total for 3 rolls is going to be then 15 times 3, which is 45 feet of paper. Okay. So when we talk about the border, we first note, now they're all going to be the same because they all have 3 rolls of paper. Okay. So we take 3 rolls of paper. Each roll is 5 yards. We don't want to work with yards. Yards is confusing. Turn it into feet. So I took my yards, turned it into feet. Okay. Now we've got 3 rolls total. So we've got 45. If I want to put border paper on this room, what does that look like? Let's draw our picture again. When we wallpaper the room, we don't care the height of the room. That doesn't matter. But let's look at the room. And let's try and put a border around the room. Okay, if I try to put the border around the room, it looks similar to that, doesn't it? Okay. And this room is 9 by 12. So if I want to border this room, it's not going to be in square feet. It's not an area anymore, right? It's just the length of paper I need. So let's look at the front and back. For the front and the back, we're looking at this room that's 9 feet long. Okay, so if I want to paper this room, I'm going to need 9 feet of paper, but I'm going to need a front and a back room. So I actually need 9 times 2, which is then 18 feet of paper there. Now we're going to do the side. And for the sides, we do the same thing. And we'll shade that so you can see this is 12 feet here. And we have 2 of those, so we need then 12 times 2, which is then 24 feet. Okay? What's my total? Total, yep, is going to be 18 plus your 24, and that is, what, 32? Yep, sorry about that, yep, 42, my mistake there, 42 feet. Can we paper the room? Yep. Yes, we can paper the room. Okay, and why can we paper the room? 42 is less than 45. So 42 feet is going to be less than that 45, so I know that I can paper the room. Now, what you're going to have to do is you're going to have to finish it. There are 5 other decorators, and you're going to have to do the exact same procedure for all 5 of the decorators. And I want you to list out which decorators can either paint the room, paper the room, or both. And most of the decorators are going to be able to do that, but there are a couple of them that won't be able to. Some decorators can just paint it, some decorators can paint it and border it, and there are a couple that can't at all. So let's now talk about our homework. What's our homework for next week? We covered quite a bit of material today. Our homework for next week is you should be able to do 1.4, should be able to do them all. 1.5, should be able to do them all. And 1.6, we should be able to do them all. Next week, what we're going to do is we're going to go over questions from our homework. We'll cover 1.7, and then we'll start reviewing for our first exam that's going to be the following week. So we've got a little bit of time before our first exam. As we just went over 1.4, 1.5, and 1.6, and I'll see everyone then next week. Make sure you bring back those surveys.